Lecture 7, Part 3. Let's continue to consider this typical reinforced concrete beam details and schedule. The bars are normally bent and scheduled in accordance with the recommendation of building standard 8666. These give details of the common bending shapes, the method of setting out the bending dimensions, the method of calculating the total length of the bar required, and a shape code for use with data processing routines. A preferred form of bar schedule is also given, which has been designed to give easy cross-reference to the detail drawing. A typical reinforced concrete beam detail and schedule is shown here. All other reinforced concrete details shown in this volume are intended to show pattern of reinforcement rather than detailing practice, and are therefore shown in full without a reference to bar diameters and types. Here you can see a member beam 1. Beam 1 include bar mark 1, 2, 3, 4. This is a 4, yes. So, 1, 2, and 3. Then type and size of this bar, number of members, number in inch, total number, length of each bars, and of course shape in accordance with building standard are shown all dimensions. The bent reinforcement should be fabricated into cage for column and beams, and into mats for slab and walls. Then the bars cross or intersect. Where the bars cross or intersect or one another, they should be tied with soft iron wire, fixed with special wire clips, or tack welded to maintain their relative position. Structural members that require only small areas of reinforcement can be reinforced with steel fabric, which can be supplied in sheets or rolls. Where exposed ends of fixed steelwork are present, such as this vertical starter bar, plastic mushroom cups are fitted as a temporary measure to prevent operatives from injuring or impaling themselves. Steel fabric for reinforcement of concrete is covered by building standard 4483, which gives 4 basic preferred types: A for square mesh floor slabs, B for rectangular structural mesh, also for slabs, C for long mesh rods and pavements, and D a small diameter wrapping mesh binding concrete fireproofing. The fabric is factory made by welding or interweaving wires complying with the requirements of building standard to form sheets with a length of 4.8 meters and a width of 2.4 meter, or rolls 48 meter and 72 meter long with a common width of 2.4 meter. Each type has a letter prefix which is followed by a reference number, which is the total cross-sectional area of main bars in square millimeter per meter width. Typical examples of reinforcing bar and fabric we already have considered. And what is the welded wire fabric and what is advantages of this welded wire fabric? This is a type of reinforcing grid of wires spaced 6 from 6 to 30 centimeter apart. Typical use: horizontal surfaces, comes in mates or rolls. Advantages: labor savings. The fabric mesh is factory made by welding or linking wires. Each type has a letter prefix which is followed by a reference number, which is the total cross-sectional area of main bars in square millimeter per meter width. This is a square mesh fabric. Prefix A. Square structural mesh fabric. Prefix B for slabs, and this is also for slabs. And this is a long mesh fabric. C for roads and pavements. Steel fabric mesh for the reinforcement, we already know that has 4 basic preferred type: A, B, C, D. So D, a small diameter mesh for blending. Before placing reinforcement into the formwork, it should be cleaned, as the presence of any dirt could reduce the bond and the strength of the reinforced concrete. Reinforcement must have a minimum cover of concrete to give the steel protection from corrosion due to contact with moisture, and to give the structural member a certain degree of fire resistance. Formwork must be of a material that will not lead to corrosion of the reinforcement or crashing of the hardened concrete. Cover as a means of influencing durability. Cover to the reinforcement is generally regarded as the most important line of defense against reinforcement corrosion. And is defined as a distance between the outer surface of the reinforcement and the nearest concrete surface. It's always the least distance is indicated here. Concrete cover is required for three main reasons. First, to ensure the reinforcement is not affected by the deleterious materials from the environment. Second, to ensure the encased reinforcement is fully bonded. And third, to provide resistance to fire. Curing of concrete. This is a process of maintaining enough moisture in concrete to maintain the rate of hydration during its early stage. If not properly carried out, affects its strength, water tightness, and durability. Methods of curing are bonding or immersion, spraying or fogging, weight coverings with burlap, cotton mats or tacks, plastic sheets, polyethylene films 0.10 millimeters thick, or membrane forming curing compound, steam curing. Concrete curing. After hardening, concrete gains strength with time, and it usually has sufficient strength at 1 to 2 days to be self-supporting. At 28 days, it achieves its design strength. This is the strength designers use to size elements in a structure. In reality, concrete continues to gain strength throughout its life, so any increase after 28 days is a reserve. Achieving its design strength depends to a large extent on the care the concrete is given in the first few days of its life. In particular, the concrete needs to be cured when young. This is an important aspect of concrete management and requires future explanation. When concrete hardening, this occurs as a result of the hydration reaction, and for cement to hydrate, water must be present. If concrete is taken at an early age and dried in an oven, the strength development is arrested. When wetted again, there is some future increase in strength, but never to the extent with an equivalent unheated concrete. Curing is a process which ensures the concrete has sufficient moisture to hydrate continuously, especially during the first week or so of a concrete's life, which is this critical period. Concrete can be gently sprayed with water, wrapped in a damp hessian, or wrapped in polyethylene to prevent evaporation, or sprayed with a curing compound. This latter material again prevention evaporation from the concrete. So here you can see a compression strength in percent of 28 most cured concrete. H days in air enter time. This is in air after 3 days, in air after 7 days, and this is most cured enter time. The precise relationship depends on many factors, including the type of cement used and the environmental conditions at the time of and immediately after manufacture of the concrete. Of course, the relationship between concrete strength and age depends on the type of cement used. This is a rapid hardening Portland cement, or maybe different other materials. The finer grains and different raw material used in this cement enable water to access a larger surface area of cement and so react more quickly than if a coarser grain cement with different constituents like OPS, OPC were used. The result is that the rapid hardening Portland cement gains strength more rapidly in the early days than the ordinary OPS, OPC. So concrete curing must be kept moist. Moisture needed for hydration, development of strength. Testing of concrete. Consistency and workability. Consistency is a measure of its wetness and fluidity, measured by the slump test. Workability dependent on water content, fineness of cement, and surface area of aggregates. Compressive strength, determined using 3, 4, or 6 diameter cylinders having twice the diameter in height. Depending on amount of cement, curing, days after casting, fineness modulus of mixing aggregate, water cement ratio, and temperature. Tensile strength obtained using split cylinder tests. Flexural strength determined by third point loading. This is a modulus of rupture. Here you can see a sample collected. Slump cone filled, cone removed, and concrete allowed to slump. And here slump measured. So testing of concrete we already understand. The current compound is designed to degrade after 6 or 8 weeks. Figure indicates the strength gain of a typical concrete. The precise relationship depends on many factors, including the type of cement used and the environmental condition at the time of and immediately after manufacture of the concrete. So, concrete strength increases before 6 months. So you can see a concrete strength depends from the months, from the days, from the concrete age. Top of slab being protected during cold weather, you can see here. Using polyethylene to prevent evaporation or sprayed with a cooling compound. This latter material again preventing evaporation from the concrete. Pre-stressing. Theory. Place all the concrete of the member in compression. Take advantage of concrete's compressive strength of the entire member. So, when a concrete beam is pre-stressed, all the concrete acts in compression. So you can see a compression in concrete for this beam. When the off-center location of the pre-stressing steel causes a camber in the beam. Under loading, the pre-stressed beam becomes flatter, but all the concrete still acts in compression and no cracks appear. So, here you can see a pre-stress diagrams, bending stress diagrams. So equal these diagrams under loading. Advantages of pre-stressing. Increase the load carrying capacity, increase the load carrying capacity, increase span length, or reduce the member size. Prestressing, pretensioning. The first step in pretensioning is to strengthen the steel, prestressing strands tightly across the casting bed. Concrete is cast around the stretched strands and cured. The concrete bends to the strands. When the strands are cut, the concrete goes into compression and the beam takes on a camber. In post-tensioning, the concrete is not allowed to bond to the steel strands during curing. After the concrete has cured, the strands are tensioned with a hydraulic jack and anchored to the ends of the beam. If the strands are dropped, as shown here, higher structural efficiency is possible than with strength strands. Cable positioned prior to concrete placement. Stressed after concrete placement and curing, and generally performed at the job site. Here you can see a large conduits for placement of post-tensioning cables on a bridge. So, thank you very much. Bye.